Get that part to stick that on there.
Okay, thanks everyone for coming. Looks like a nice turnout tonight. So next week we've got another cool seminar. It's going to be and he's talking about crime scene ecology, and in some ways the ecology of a homicide. So I think it's going to be pretty interesting. So I hope everyone can show up for that. But that's all I'm going to say. I'm going to turn it over to Deb, Ross, and Eric. So take it away.
Oops, I don't need that. I have this. All right. Thank you, everyone, for coming today. Told Johnny didn't have to do a formal introduction of us, that we would each introduce ourselves. So I'm Deb Bathke. I am the Nebraska State Climatologist. I've been formally in this position for just over a year. And upon taking this position, I don't know, inherited, is that the right word? Inherited the state climate assessment report and quickly looped others in to help with that. And I also have joining me here today, Eric Hunt with Extension. He's got a full long title that he can say when he starts, but he's an Extension meteorologist and climatologist. And then Ross Dixon from the Department of Earth and Atmospheric Sciences. And we are talking about the report, I would say recently released, but it hasn't been released. About 15 minutes ago, I tried to submit it, but it's too large to email, even when it's compressed. So we'll see what happens. I sent a link and we'll go from there. So the report is titled Understanding and Assessing Climate Change, Preparing for Nebraska's Future. Okay, what am I doing? Clicking this one. So why did we do this report? Well, first of all, it was required LB 1255, and I think that was passed in, was that 2022, 2023, something like that. And so that bill stated that the Institute of Agriculture and Natural Resources would update the 2014 report that was due. And so we were required to do that, I guess, by contract from the state legislature. Since then, this is the new acronym, Nebraska Department of Water, Energy, and Environment. I think it just changed, so I'm trying to remember it. They have received a $307 million grant from the Environmental Protection Agency. The last time I checked, a couple of weeks ago, that money is still on. As far as I know, you can check the One Red website to see if there are any changes to that. I'm not exactly sure what's been happening with that, but they do mention using this report and working with the State Climate Office as they approach the climate mitigation planning for the state of Nebraska. And that's, I think, largely focused on agriculture. So this report should help with that. The 2014 report was highly visible, and we have Kim Morrow from the city of Lincoln here. She was involved in that as well and did a series of roundtables associated with that report. And I think between the 4 authors on that report, we did probably at least 100 presentations just around communities and things like that. Some other benefits of the report, I met a lot of people in the university, even though I had been here, 17 years at the time. I was connected to a number of researchers that I hadn't met, and I think that it has really helped us to create a community focused around research and education and outreach on climate change. And then another part of this report is we used it to identify some gaps and some opportunities to either educate about climate change, of research that needed to be done, or a variety of other things. And I'll talk about some more of these in a little bit. Our approach for this report, kind of use these 3 icons here to get to what I'm talking about. So while the science behind climate change, greenhouse gases cause warming, is pretty simple. We've known that for a long time. the science of how it will impact communities is complicated. It spans multiple disciplines, ranging from applied climate science to, we've got John over here in energy. I don't know which other authors we have on, but we have some social scientists that were involved in the report. We have ecosystem science folks involved in it, and now everything escapes me. Researchers involved. I'll show you the whole list in a minute. So that science is very interconnected and complicated. Addressing climate change through policies is also extremely complicated. It's nothing that one individual can do. It's nothing that just the city of Lincoln can do, or the state of Nebraska, or the United States can do. It affects all levels of government, vertically and then also horizontally across the whole globe. And then it's also a matter of balancing concerns. How do we balance these short-term economic interests with the longer-term needs and protection of the environment and the ecosystem? And because of all of these things that need to be addressed, now this is a pretty, I think it's big because the last report, we had 4 authors. This time we have 21 lead authors. We had 17 additional contributing authors, and I have some of those contributing authors in the room. We've got, I guess Jerome was the lead author. I forgot to point you out. We have Lindsay. We have, who else was a contributing author in here? Larkin was a sounding board. So we had a 13-member advisory group guiding us through the writing of the report, helping us to decide which topics to cover, how to address things. We had folks from UNL, the Med Center, Creighton, and the Nebraska Indian Community College as lead authors on the report. So that covered 4 campuses. Here's the whole list of programs from the NU, just the NU system, that were involved in the report in some capacity, whether it was serving as a lead author, a contributing author on the advisory group, or a member of our review team. And so our review team included subject matter experts, not just from UNL, but also from the federal government and other universities. We wanted to replicate that process of science and make sure that we were putting out the best information that we could. So this report is organized into a few different components. The first level of it, and that everything is based upon, is the physical science related to climate change and climate change in Nebraska. And that's primarily what I'll be talking about, as will Eric and Ross. So that includes some global context information. Eric will be talking about specific trends and things that we've seen in Nebraska. And then Ross will give us the perspective on what we can expect in the future. In addition to that, we had focus topics that ranged from water to energy to agriculture to ecosystems to communities. I'm going to forget some, to indigenous peoples. What am I forgetting? Social justice, the response of faith communities, perceptions and beliefs on climate change. I'm sure I'm forgetting some, but I will have a slide that will show all of those later. So we have that beliefs and attitudes part. That's a new addition from the 2014 report. Another new addition is we have a whole supplemental report that is focused on opportunities for mitigation, adaptation, and resilience. So here's what we're talking about. I'm going to talk just a couple more minutes about some global context and some context of where we are with the science, and then Eric and Ross, and then I'll touch on some of that additional information and then end with our next steps today. So how many people have seen this figure before, the climate stripes? I have a skirt that has those on there. I didn't wear it today, but so this is the global change in temperature without any numbers, the anomalies from the beginning of the instrumental record in about 1850 to the end of 2024. And was it last year or the year before that they had to add a new color? I can't remember, but they had to add an even deeper shade of red because that change has passed another threshold. And so if we look at this timeline of change, we can see that it was a lot cooler if you find when you were born. So for me, 1970, we were still in the blue anomalies. So we've seen this change, but climate science has been happening pretty much over this whole timeline that we've seen. And I like to include this because we hear the argument a lot that, and we just heard, Eric and I just heard it yesterday, I don't know if I'm really on board with the science of climate change. I don't know if I believe that. Well, climate science, the early discoveries of the greenhouse gases have been around since 1830, 1838, 1835. So this is not new late breaking science. This has been science that's been going on for a long time. So, oops, my animations aren't right. So in the mid 1800s to about 1900s, we had those early discoveries and concepts. We had the proposal that carbon dioxide is a greenhouse gas. It was demonstrated in a lab. Theories were created. All of that was happening. And then we had a little bit, oh, well, no. We had a little bit of a break there for some world wars and things like that, where maybe climate science wasn't the priority. But then we started with monitoring carbon dioxide levels in the atmosphere, comparing that to temperature records, doing the very early climate models about this cause and effect relationship. And if you have questions on that, Ross is your climate modeler, so I'm gonna punt that his way. So, you know, those early efforts happened in the 1940s to the 1980s. Interestingly enough, and I learned this from one of Eric's talks last fall, because I missed the article on it, is that in 1978, Exxon's own scientists alerted their owners and their board that carbon dioxide was leading to an increase in temperatures. And they modeled this, and that model was pretty accurate. And in fact, scientists have been accurately predicting the effect of increasing greenhouse gases on climate for almost 50 years now. And so Exxon knew that in the late 70s. In 1988, Jim Hansen testified before Congress saying, hey, this is happening and we need to be concerned about this and we need to address it. In the maybe 90s, early 2000s, and continuing on, we started to get some international action. We had the Intergovernmental Panel on Climate Change doing global assessments of climate. We had the Kyoto Protocol and the Paris Accord and international treaties addressing it. In 2014, about the last time the last report was out, a research article came out that said that 97% of all climate scientists had come to a consensus that global warming is happening and it is primarily attributed to anthropogenic causes, so to burning of fossil fuels. And then more recently, the things that have been taking place are what we call attribution science. So can the increase in the amount of rainfall that we see in hurricanes be attributed to global warming? Can the decreases in precipitation or the increases in drought, can we attribute that to global warming? So that's kind of where we are with science now. Through every state since those global assessments began in 1990, scientists have made statements based on their understanding of the human effect on climate science. And so on the bottom, I didn't have a chance to finish this as Lindsay suggested, but on the bottom, we have those global assessments. The second row on top, around the same time or shortly following those, we had national assessments that happened in 2000, 2009, 2014, 2000, I don't remember the date on that one. And then I think it was 2000, I don't remember. And then the most recent one was November of 2023 it was released. But we also have our Nebraska assessments. on top of that. So the Nebraska assessments don't stand alone. They build off the knowledge that we've gained from these international and national reports. And through each of them, I put these little balloons here to show you how the science has changed over that. So in the 1990, the first IPCC report, maybe that was 1992, it said an unequivocal detection of a human influence on climate change. We might not see that, probably won't see that for a decade or maybe more. So that's where we were in 1990 when I was in college. Freshman in college, sophomore in college. 1995, I remember reading the whole 1995 report in a graduate class. That shifted to the balance of evidence suggests a discernible human influence on global climate. By 2001, they're saying we have even more, it's even stronger than what we saw 6 years ago. By 2007, we're saying most of the increase is very likely due to humans. And they were saying that with a 90%, I think it was a 90% confidence level. By the 2014 report, that language was shifted to extremely likely that humans have been causing that. And that was expressed with a 95% confidence level. And then now in the most recent report in 2023, it's unequivocally humans. And just to point out a few things that I found that I like to point out is that, and I said one already, computer models have been, this is some things that we didn't know in 2014. There hadn't been a study on how accurate computer models have been in predicting the climate. And they've been very accurate over the last 50 years. That 97 consensus of climate scientists has shifted to greater than 99%. So I think it comes out to 99.7% was the most recent number that I saw. And then the most recent IPCC report used this language that says that the influence of human activity on the warming of the climate has basically evolved from theory to an established fact. So there is no debate. That's what this all comes down to. There is no debate among scientists as to whether climate change is happening because of humans. So I have to show this graph that shows the temperature change over the last 2,000 years, shows an anomaly. The scale is on the right is 1 degree Celsius. It's about 1.8 degrees Fahrenheit. So we can see from the we are here dot clear up there that our temperatures are higher than they've been over the last couple thousand years. And we can also see that that rate of increase is faster than it has been over that amount of time. And when they extend it way back using ice core records and other records, scientists have found that it's 10 times faster than when we came out of the last ice age. So that's how much faster. These changes in global temperature are having impacts all across the globe. The level of impact and the type of impact that you get depends on your location, so your latitude, your elevation. It depends on your socioeconomic status. It depends on how prepared are you? Do you have adaptation measures in place? Have you worked on building resilience to those? It tends, and what am I missing? What else it depends on? The background climate of the area as well. And those are some of the things that Eric and Ross will be talking about. And I don't expect you to read this, but I want to point out this figure that shows that the effects of climate change are complex and interconnected with society. And I'm really proud of this figure because our undergraduate intern, Camille Schifrin, made this figure for us to highlight it. And she has it all color-coded where you can follow it through. For example, a hurricane can increase power outages, which can then lead to, I can't read that there, but if you have increased power outages, then you could have food that's spoiling and then people could get sick, or And then you have a CDC response, or even with power outages, we know that LES and OPPD respond to that. So we have, it's just intertwined and it's complex. And I do have some case, you can look at this figure in the report and more closely and you can read it. But I also, and I'm missing one on here, I also have 5 case studies in the report that kind of go through some of these interconnections. So there's one that's focused on if we have, how do we, with global warming, how do we keep getting these cold snaps in the winter, the miserable February? How is that still happening? I thought the earth was getting warmer. So we have a case study talking about that and relating it to years. El Nino, La Nina, most people have probably heard of that. Are we moving into La Nina? The indicators are that we're moving into La Nina. So we have a case study talking about some El Nino and La Nina years and the increased dryness or wetness and flooding associated with those years. We talk about how climate change can cause risks to national security, whether it's melting sea ice in the Arctic or it's increased flooding and heavy rainfall events and flooding and melting that led to flooding like we saw in 2011 and 2019 that affected Offutt Air Force Base. We talk about the widespread and long-lasting toll of hurricanes and how that, wouldn't think that does a hurricane influence Nebraska, but one of the things that came out of Hurricane Helene last fall is that it impacted the IV fluids that were available to the country. And it was what, I can't remember, it was 60 or 80% of Nebraska's supply of IV fluids was impacted because of that one factory that was taken out by Hurricane Helene. And so hospitals across the region, including the Med Center, were rationing IV because of that shortage. And then again, whenever there's a disaster, Nebraskans are there to help. So we had everyone from college student organizations to communications experts to public power going down to help out after that. And I think there's an interesting fact, and I wish I could remember it off the top of my head about the increase. So like, for example, when we have the National Guard respond to an event for flooding and disasters and things like that, that's taking away from their training. And I can't remember what the increase was, like a 12-fold increase in the number of disasters that they've been responding to over the last decade, I think it was. Oh, there's the new slide. Okay. Wildfires was the last one. So I talk about the increasing wildfires and wildfire season that we've seen and how we've even seen the impacts of wildfires in Canada, affecting our air quality here in Nebraska. So just because you don't necessarily see a direct impact doesn't mean we're still not being impacted in Nebraska. And with this, I'm going to turn it over to Eric to talk about discovering the world with SNR 9.
Thanks. All right, thanks, Deb. Thanks for coming. I am Eric Hunt. I'm an assistant extension educator of agricultural meteorology, climate resilience house here in the School of Natural Resources. It's a mouthful. I just want to acknowledge Deb also contributed to this chapter, and Camille Schifrin, our intern, also contributed to this chapter as well. So I'm going to be showing you a lot of graphs the next, say, 10 to 15 minutes. So just for context, anytime you see this orange line, that is a long-term trend line that is basically going back to the late 19th century through, basically near present time. The line is representing a short-term trend going back to 1980. Anything you see in blue here represents temperature anomalies below average, and these are temperature anomalies above average. So if we look at the long-term trend, we see 6 degrees Fahrenheit warming over the long term, about double that in the short term. Now, notice that we still occasionally have had years in Nebraska that were cooler than average of the 21st century, but they have become fewer and farther between. Also, I have to point out the gray line you see here is a 5-year moving average. You'll notice that we have not been below the 5-year moving average probably since about the mid-1990s, or the last time Nebraska was a dominant football power. So this is the map by climate division. So Nebraska has 8 different climate divisions, and numbered from Panhandle to northeast down to southeast. And if we compare 1895 to 1960, so that period of 65 years compared to 1994 to 2023, so we take the latter period minus the first period, we see pretty big temperature changes across the board. Warmest in the Panhandle, but pretty much the entire state, every climate division, pretty much every station in the state, as we have long-term records for, shows at least 1 degree of warming between those periods. So if we go and look at the longer term picture, the winter season has our biggest change. For those of you that have lived in Nebraska for a long time, you probably noticed our winters have gotten noticeably warmer. And indeed, if we look at the long-term picture, yes, that is indeed the case. Our long-term trend is definitely upward and it is positive. The short-term trend is actually flatter. Now, I know that might seem strange considering we hardly ever have snow on the ground here in December anymore. We hardly ever have ice on ponds here, until closer to sometime in January. This is more a reflection of we have had a lot of cold weather in February in recent years. Deb showed a slide earlier talking about cold snaps in February. That is very much tied toward polar vortex stretching, which is affected to some degree, perhaps to a large degree, by anthropogenic climate change. So does it mean winters? We generally are seeing winters that are starting later than they used to, and are a little bit more erratic, certainly less regular snowfall. Summer temperatures are definitely going up as well. In the short term, even though that is also a little bit less story than what you just see on this graph. So for example, that short-term rise in temperature that we see, I forget exactly what the numbers are, but it's in chapter 3 of the report. But that is a reflection of, we are seeing significant June warming. So Deb talked about 1990 was sort of a year for climate science. So in 1990, June 1990 was the 8th warmest June on record to that point. June 1990 is now the 30th warmest in this country's history. So that means since 1990, basically 2 out of every 3 years have been, that Junes have been warmer than the one in 1990. What's not shown here, though, is that there are some spatial differences across the state in terms of warming. So, for example, here's the June slide. So we see the June's, upper temperature is very, very sharp. We really long-term average in June anymore. We were not this year either. That is somewhat a reflection of, if you think about June in this region of the country, it used to be more of a transition month from traditional spring weather to more true summer weather. Because of the polar shift in the jet stream earlier, we are seeing summertime temperatures and just summertime conditions getting here a bit earlier. So there's all sorts of impacts that can happen from that, but I'm mostly just going to talk about the temperature trends today. But there is, even within that short-term trend, the short-term warming signal, we do actually have a bit of a warming hole with maximum temperatures, particularly in the middle of summer, say from like right around the 4th of July through a good portion of August. And if we look at the number of days with maximum temperatures over 95 from the 1991 to 2020 period, compared to 1951, 1980, most of the eastern half of the state, through a lot of the Corn Belt, the temperatures we've actually seen fewer days over 95. Now, I think there are probably a lot of reasons for that, but probably the most common reason attributed to that is the sheer amount of biomass that we have in this region of the country in the form of corn and soybean, probably a few other crops as well, but predominantly corn and soybean. Corn, has a very high evapotranspiration signal and is fundamentally harder to heat up a moist atmosphere than it is a drier one. You'll notice though that here in the Panhandle and getting into northeastern Colorado, we have a different signal. You get the more semi-arid part of the state where we have less agriculture, certainly less corn, less irrigated corn. We have seen temperatures, we are seeing more days over 95. As we'll also talk about later, this is not a trend that we may expect to continue for the long term. We also are seeing our fall season warm very quickly. So September has become, I kind of joke that September now is August light. Now it was cooler earlier this month than maybe what's been, for some reason, it's been pretty warm here the last few days. And if you look at the forecast for the rest of the month, it's generally pretty warm. So we're generally following the same path that we've been on in recent years. So again, this is kind of a similar story, a lot of up and downs through time, but since the start of the 21st century, predominantly above average, in some cases significantly above the long-term average of the basically the entire 20th century. Okay, so that's the temperature story. I'll move into precipitation. I have a few, don't have quite as many slides here. This is every bit as important, perhaps even more so than the temperature one, because extreme precipitation does cause a lot of impacts. Just saw that last night. McCook had almost a quarter of a year's worth of rain in a couple hours yesterday afternoon and last night. So we look at the precipitation trends. It's a lot less exciting than temperature. It's relatively flat. It is technically positive in both the long term and the short term. And you notice that, if you go back through time, you see the Dust Bowl days in the 50s and some dry years in the 70s and, wet years in the 80s, 90s, and then a pretty wet period from mid 2000s to about 2019. So we definitely have had some wetter years, and the 5-year moving average is actually pretty significantly positive. This decade so far across the state, especially 2020 through really through earlier this year, really has been pretty dry. This year's last few months have been pretty good for the state in terms of drought recovery. And if we look at the the precipitation differences, similar periods, same periods, 1895 to 1960 compared to 1994 to 2023, we see that every climate division in the state has gotten wetter. North Central is kind of the bigger winner. Now, again, there are fewer stations up here, so this maybe isn't, we take that one with a little bit more of a grain of salt than some of the other climate divisions across the state. But regardless, the story is that the state has gotten wetter. Now, that doesn't necessarily mean that that can be a good thing, but it doesn't necessarily mean that we're going to have healthy vegetation. Remember, warmer temperatures means higher potential evapotranspiration, higher demand. So that may actually mean that we could have more drought and more water stress, even as we see increased precipitation in the future. What we have seen is an increase in precipitation in the winter, not shown here, but you'll see in the report. We also have seen a decent increase in precipitation in the spring months. Now, that can be good. That means that we maybe are getting the recharge that we need for agricultural purposes, for ecological purposes. But from agricultural standpoint too, if we're getting a lot of precipitation at the wrong time, that means that farmers are not getting their crops in the field, and they tend to get pissed if their crops are delayed getting in. In part because if they can't get them in until later in May or early June, then they have a risk of not getting their crop to maturity before a freeze. Summer, kind of a mixed bag. We see a slight decrease in precipitation in the Panhandle. We are seeing some decreases in precipitation here across east central and southeast Nebraska, the areas of the state where we predominantly have more rain-fed cropping systems. So if you go east of Lincoln, you will see very few pivots. It's more like the I states. This is the region of the state we have seen a little decrease in precipitation. We have seen a bit of increased precipitation out here. I would point out, though, that none of these trends are statistically significant across state for precipitation in summer. And with the warmer temperatures, you almost have to have a bigger increase in this to offset what we possibly lose through evaporation. Last slide I want to show is just a drought slide. So anything you see down here on the bottom in the brown means basically drought or drier signal. This is an index called the Standardized Precipitation Evapotranspiration Index. If you are interested, I'd be happy to talk about it. Just for purposes here, if you see blue, it means we are at a wetter period across the state. Brown means you're a drier period. So if you look at in the last 20, 25 years, we have actually not had as much drought maybe as we've had historically, but when we have had drought, they've been pretty good ones. And this does not necessarily show, this goes to 2022. This doesn't show what we hit in 2023. So particularly in this part of the state, what we had in the spring, early summer 2023 were some of the worst conditions that we'd had since the 1950s. That's my contact information. A lot of you know how to get a hold of me. I'm going to turn it over to Ross.
Thank you. All right, I'm Ross Dixon, Department of Earth and Atmospheric Sciences, and I led the chapter on projections of Nebraska's future climate with my graduate student, Emmanuel, and a student from SNR, Michaela Wood. And so I want to start by talking about where do climate projections come from, right? We have the observational data, but where do we get the information we're going to see in the report? And so the first thing we have to do is think about how are emissions going to change in the future. So we have oh yeah, I can point with this, I suppose. We have a large number of scenarios for different projections of carbon dioxide and other greenhouse gases. So for this report, we chose one which is the business as usual high emission scenario, and we also chose emissions so that we had a good range of different prospective futures with different amounts of greenhouse gas emissions. Those emissions are used to drive numerical Earth system models, climate models. And there are groups across the entire world that are putting together simulations of the Earth, right? There is no second Earth. We can't do a controlled experiment here, so we have to use numerical modeling. All of these models have different ways of representing subgrid processes, even the dynamical cores, what processes are represented, and how do you take really, turn it into math, turn it into a numerical model. Right? This is what my research group is very interested in. But we get output from 23 of these different models, and that's important because none of these models are the Earth, right? They're like planets, right? And these simulations have a close resolution because they're run for the entire globe for long time periods. Usually they're around 100 to 200 kilometer resolutions. So to get higher resolution information that's useful for impacts, for regional impacts, we like to do downscaling. And I'm a dynamicist, I like dynamical downscaling, but for the report we used from the local constructed analogs to go from that much closer resolution to 6 kilometer resolution. So this is going to give us some really good climate information, projections for the future. This is a plot showing Nebraska's annual average temperature. We have the historical period in gray here with the observations in this dashed line, and this is the average of those 23 different models for the historical period across all of Nebraska, which you see matches the observations very well. A high emission scenario, we have a large amount of temperature increase across the state by the end of the century, and even some large amount by the mid-century period. I'm going to be showing you plots for mid-century, which is 2040 to 2065, and end of century, which is 2075 to the end of the century. So by 2050, the statewide temperatures are expected to increase by 2050, the mid-century period, these temperatures are expected to increase by around 6 degrees Fahrenheit. By the end of the century, they could range from 7 to 11.5 degrees Fahrenheit, right? This is currently in the historical period, the average temperature of Oklahoma is around 60 degrees Fahrenheit. So we're thinking about our state being more in the realm of the temperature of Oklahoma. We can also break this down and think about daytime and nighttime warming. And these are for our mid-century moderate emissions and high emission scenarios. Well, what do we see? Okay, it's warming everywhere. The dots here indicate agreement across these 23 models. These are areas where 80% of the models have the same sign of change. We see a much stronger signals in terms of warming in the summer. We see significant warming even at nighttime. This is extremely important for agriculture. Dr. Harkamawalia studies a lot of this impact of nighttime temperature on crops, and that's super critical. By the end of the century, we are seeing extremely large temperature increases, right? We don't get that same spatial pattern that Eric sees in the observed period. And there are a couple of hypotheses I have for why that might be. But we're seeing really large increases in temperature across the entire state, across all seasons, in the daytime and the nighttime. If we're thinking about extremely hot days per year, this top one is showing days per year where the maximum temperature is over 90 degrees Fahrenheit. And this bottom one, max temperature over 100 degrees Fahrenheit. In the historical period, this ranged from 0 to 10. But in these end of century periods in moderate and high emission scenarios, looking at number of days over 100 degrees Fahrenheit, you know, in the high emissions case, approaching and even over 100 days per year, as not so pleasant, eh? We also care about the extremely warm and extremely cold nights per year, especially if we're interested in pests, right? Another really big agricultural impact is cold winters are good for killing, having less pests. And we're seeing that these cold nights per year is going from 20 to 25 all the way down to 0 to 5 days per year where that minimum temperature dips below 0 degrees Fahrenheit. And we see that these very warm nights of the year are going to increase, especially towards the eastern part of the state. Precipitation is much more challenging than temperature. You'll note that there's a lot fewer here by the mid-century. So here's our moderate emission scenario and high emission scenario. We get a lot of agreement for an increase in precipitation across the winter and spring, which is congruent with what Eric was showing, and some slight drying signal. Don't agree. This is also not statistically significant. Towards the end of the century, this signal really pops out much stronger. Drying across the summer and an increase in precipitation across the spring and winter. This can also be seen in the expected frequency of extreme precipitation. These are days where precipitation is over 2 inches. These are days where precipitation is over 4 inches. We see this increasing. This is not my favorite color bar. I probably should have done something else with this plot. But this is an increase, especially in these most extreme days. That these days with precipitation greater than 4 inches are increasing, especially in the southeastern part of the state. And finally, we see changes in this maximum number of consecutive dry days per year, right? This is our nice east-west gradient where the western part of the state has periods which are more consecutive dry days. And these models indicate that this could change, right? That this period of no precipitation, this maximum period of precipitation may increase by the end of the century. So this is kind of congruent with this idea of extreme precipitation events may be fewer and more spread out. When they occur, they may be more intense, right? This is what we're seeing in these projections for Nebraska. In terms of the gaps and needs, what I hope you've noticed is that every change that I just showed you is more extreme in the high emission scenario than the moderate emission scenario, right? Decreasing greenhouse gas emissions can avoid the most significant changes and impacts. The continued observations of these climate indicators is essential for monitoring, right? Understanding where we are heading. This includes opportunities for citizen science monitoring. And finally, all of these were statistical downscaling techniques. It would be really nice to do some dynamical downscaling for the state of Nebraska. This is all based on temperature and precipitation, fields which are able to be statistically downscaled. But with the ability to do dynamical downscaling, we can get things like wind speed, humidity, some of these impactful climate variables that would be useful for helping communities prepare for changes in Nebraska's climate. All right. And let me bring your slide back up. There you go.
All right, can you hear me? Okay, so this is just the very beginning. I think I need to move that up higher. This is just the very beginning of the report that we talked about today, just the climate side of things. We have, let's see, 10 other chapters to the report where we hit on some special focus topics that we selected with our advisory group. And these include impacts to water systems, energy, which was led by John Hay over here. I think we probably have some other authors on as well. Ecosystems, which was written by our USGS cooperative. I'm going to get that name wrong. What is it? Cooperative, what's it called? Fish and Wildlife Center. We have agriculture, which was written by Andrea Bash and Nick McMillan, and human health from Jesse Bell and Christina Kitzinger from the Med Center. Chapter 10, Communities and the Built Environment, which was written by Zhenghong Tang from Community and Regional Planning and SNR, Tanya Haig with the National Drought Mitigation Center, Indigenous Peoples by our authors at the Nebraska Indian Community College, Climate Justice and Equity by Ryan Wishart, who's at Creighton, The Response of Faith Communities, which talks about opportunities for faith communities to address climate change, and that was written by Dan DeLeo at Creighton. And then I'm missing one on here, Climate Justice and Equity. Okay, the last one should have been Beliefs and Perceptions of Climate Change, written by Heather Aiken at ALEC. And we are having our interns at the Climate Center work on getting some virtual brown bags scheduled with each of these authors so that you can hear more directly from them. These are not my specialty areas, and I would not do justice to what they cover. So look forward to that, and we'll send out an announcement and post an announcement when we have those schedules so that you can listen into those if you would like. We made this diagram here to just summarize some of the impacts of climate change as they were highlighted in Nebraska. So the things that Eric and Ross talked about with more days of record-breaking rainfall, increased temperatures, more intense droughts, shift in those seasonal patterns that Eric talked about some, decreased snow cover, more frost-free days, and then what some of those impacts that you'll read about in the later chapters, which would be physical and mental health challenges, damages to infrastructure, threats to vulnerable populations, increased water demand. I know I'm trying to read it up there when I have it in front of me. Declining surface and groundwater levels. One interesting finding that I'd like to point out from the groundwater chapter is that our authors found that during the intense drought of the 2012 that we had a significant decline in our groundwater levels, which has been highlighted for the state. But during the really wet years, like 2019, that it didn't make up for those really dry years. So we see more of a drop during the dry years than we do as a recovery in the wet years. Altered energy demands and ecosystem shifts for the impacts. We also have a supplemental report, and this was required by LB 1255, that we contract with a third-party consulting firm to come up with some recommendations for the state. So we call them adaptation and resilience opportunities. So our consulting company that we worked with was Pale Blue Dot out of Minnesota. They worked on the climate action plan for the city of Omaha. Since they were familiar with the Nebraska, they were able to help us meet our really short turnaround time. And we had significantly less money than Omaha or Lincoln did to write their plan. So that's kind of why ours takes the approach that it does. So, so in this last section, the authors and the climatologist and the consulting firm work together to put for each projected hazard for the state. So whether it's increased annual temperatures, whether it's increased warmer temperatures, increased flooding, to identify potential impacts that we see. And that's for each of those additional 10 chapters. We have a table like this for each potential hazard for each chapter so that you can look at and see what might we expect with climate change from these. In addition to that, okay. In addition to that, my things aren't working right. Let's see, help. Animation pane. I'm just going to do this so you can see it. So we also have a risk assessment. So that is based on, we have the potential hazard, and then we, I don't remember exactly how we did this. Do you, Ross? We spent a lot of time thinking about this. So looking at the hazard and figuring out how confident that scientists were about that change in that hazard. So things like temperature, scientists are really confident in that change. We saw earlier that they're saying that that's fact, that that's going to happen. Based on those confidence levels that we expect and coming up with a potential risk, and this is for the state as a whole. So for the city of Lincoln, that risk is going to be different than it would be for, say, McCook, Nebraska. But it gives you a generalized risk assessment for it to maybe help with prioritizing and to provide some guidance for that. And I can get you, there's more information on that exact process in the report, and I can talk about that more with individuals later if they're interested. And then the last thing that we have, and we have these opportunities for adaptation and resilience building. And of course, when I fixed it, I didn't fix it right. And I've been meaning to count up exactly how many of these opportunities we have, but I haven't done that yet. But for each sector, whether it's energy, communities, and the built environment, indigenous peoples, agriculture, we have example actions for different levels. So example actions that could be taken by the state, example actions that could be taken by a local government or by a sector within a community or by businesses, households, and individuals. So we break it down that way. There, let's see, for this one is water. I think there were 20 just for water. So we have those for each sector. And we are in the process of getting those into a database on the state climate website where you can click on, I'm interested in water and I'm interested at the community level, and then it'll pop out all the ones related to that. So our web person who's working on this is gone for the next 2 weeks. So it'll be at least 2 weeks before you see that on our website. Our next steps and our future work for the report. The very first thing is to identify needs that communities might have or that different agencies have that we haven't already talked about in the report. So we are hoping to take this show out on the road and have some community conversations around the state where we talk about some of these results, talk about some of the things that we've identified, work to set some priorities, and the most important thing is to align resources, because We don't have money to make all of this happen, but we're going to do what we can with what we have. Our next steps include communicating this work. So a lot of this will be through our website. We're also working on some information sheets, so things that groups or communities might be interested in. I already had one request for future heating and cooling degree days for the city of Lincoln for new construction. And so we know that's something that Lincoln is concerned about. So we hope to do some 2-pagers or infographics that talk about, this is what it has historically been. This is what we would expect it to be by mid-century and end of century to help with planning. We've had some communities have brought up about how important school athletics are for community building and bringing the community together and the impact of heat on those. So we'll be doing similar types of things for communities. And Ross mentioned the downscaling of models to get some humidity and other types of data. And so wildfire is another area that we'll be trying to do some additional research to address. Other needs in future work include data collection and infrastructure. So this includes enhancing our web resources to make climate data more easily available to those in the state who want it and want to use it, but also collecting it via the Nebraska Mesonet. Promoting planning for resilience and sustainability. Also promoting evidence-based decision-making at all levels. So trying to provide some information and resources and tools to help with that process. Education, working with the school systems to college courses to informal education to help promote learning about climate change and to help increase the education about just the science of climate change, but also the options and opportunities for the future. We also think that a need is, someone asked me why has it been 10 years since you last released a report? And there was no money to do it. So one of the things that we hope to do is to try and identify a process to regularly update the report and consistently update the report. And then at the end of each chapter, each author identified research gaps and needs as well. And so to improve future reports by addressing some of these gaps and needs. Now, in light of the university budget cuts, some of these may be harder to do if those budget cuts actually go through, because I think we had 4 programs that were involved in the report that are mentioned, at least 4 programs that are mentioned in the budget cuts for the state. So, and then finally, we do have we're out of time for questions, I guess, but if you want to stay and ask questions, we're happy to answer those. Lindsay and Jerome also have some sheets of paper. You can write your contact information. We'll get back to you. Or we are starting a new podcast called The Climate is Nuts. And that is based on, and Larkin could probably talk more about the flying squirrels on East Campus. Is it the southern flying squirrel that's migrated northward, partially due to climate change? And so we thought that The Climate is Nuts would be a great way to tie in climate change, the flying squirrels, mine and Eric's bad puns about flying squirrels and jokes. But if you want to scan that, it'll take you to a Google form. You can put your question in there. If we select your question for a podcast, you could get a free Flying Squirrels of East Campus t-shirt or the little stuffed animal doll that you can throw at your family or colleagues when they're being annoying. So with that, you're free to go if you want to go. But if you have questions or you want to listen to questions, ask. If it's something related to a sector, I can see if the author's on. If not, we'll make sure to get your question to them. So thank you, everyone, for attending. We appreciate your being here. We appreciate your support in writing this report and working on this report. I think it's been harder than raising a teenager. I'm not sure, but thank you. And we're done, but we're not really done. We've got a whole new set of things that we're working on to try and take that information, make it more meaningful, make it more useful for decision making. And is there anything either one of you would like to add? No? I'll ask all your questions to Ross and Eric. Thank you, everyone. Questions? Yes. Yes.
So if like we're able, oh, right, thank you. So if a municipality like Lincoln were able to come to the table with some funding, would you be able to produce a downscaled sort of climate risk assessment?
Yeah, that would be something.
Yes.
Okay, fantastic. Thank you.
Anyone else have questions?
No.
Okay.
You guys can stay here.
Okay.
But so the Zoom people.
Zoom people can email me if they have questions, or they can go to the link there.
Okay.
Someone had a question back there.
Available or?
Hopefully soon. It has to be